So in the previous lecture, we discussed some basics of a partial differential equation. We discussed a definition of a PDE and two basic things which were order and degree of a PDE. And in this class, we will learn how to solve a partial differential equation. See, there are many ways to solve a partial differential equation, but in this class we will learn the direct integration method. But before we start, let's take a quick revision of our previous class. We discussed the definition of PDE. So what's a PDE? Any equation which has at least one partial derivatives. And minimum two variables. So this was the definition of PDE and order and degree. So the order was the highest order partial derivative present in the equation, and the degree was the power of order derivative. Okay, let's get back to our class. We will learn this by an example, which is del cube z upon del x square del y equals to cos 2x plus 3y. Question number 1. Solve the given partial differential equation. So you can see in this equation z is the dependent variable and x and y both are independent variable. By solution, we mean we have to find out the value of z in this equation. We are going to solve this for z. What is the value of z? You can see this partial differential equation has order of 3. Means it has been partially differentiated 3 times, and in this equation it has been differentiated 2 times with respect to x and 1 time with respect to y. So how are we going to solve this? For solving this, we have to integrate it. Why? Because it has been already been differentiated. So for solving, we have to integrate it with x and y, because the opposite of differentiation is integration. Okay, let's start. Here is our equation: del cube z upon del x square del y is equals to cos 2x plus 3y. integrating with respect to x, we will get del square z upon del x del y, and it will become the different integration of course is sine, so it will become sine 2x plus 3y and 2 here, and integrating constant. So what will be the integrating constant? It could be anything, like it could be c, but for partial differential equation we have two variables x and y. While we integrate it with one variable, the other one remains constant. Meaning when we are integrating it with respect to x, y will be considered constant. So the constant will be, we can assume that here constant can be a function of y. So we will write this as a function of y. It could be any function of y. So again we will have to differentiate it with respect to x. Okay, once again integrating with respect to x. Our previous equation is del square z upon del x del y is equals to sine 2x plus 3y upon 2 plus the integrating constant, which is function of y, and we are integrating it, so integration mark, and we are integrating with respect to x, so dx. So what will be the answer? It will become del square z upon, sorry, it will become del z. It will become del z upon del y, and this will be sine, the integration of sine is minus cos, so it will be cos 2x plus 3y 2 into 2 plus this will become x, so this is a constant, so it will be x fy. We will have to integrate it one more time with respect to y. So our next step will be integrating with respect to y. What was the equation? Our equation was del z upon del y. So del z upon del y will become z, and it will become cos will become sine, and there will be 3 sine 2x plus 3y upon 2 into 2 into 3, there was minus sign, plus there was function of y, we will have to integrate it dy, and we will get so we have to add one more constant here for this another function, same logic as fy, so it will become x fy dy, and function of y will become function of g by dy plus another integrating constant which will be a function of x, because x is constant for y. We are integrating with respect to y. So let's solve out this. This will become z and minus 1 upon 12 sine 2x plus 3y. Let's name this function as function, let's name it this as phi 1, which is a function of y, plus this, name this as phi 2, this is function of phi 2, also function of y, and plus hx. So this is our final answer for the partial differential equation.